Hey everyone, and welcome back. Today we are getting into something really cool: how to take a general, all-purpose large language model and turn it into a specialist. We're talking about teaching it a very specific job, making it an expert just for you.
So here's how we're going to break it down. First, we'll get a handle on the basics. What even is fine-tuning? Then we'll see how it stacks up against other methods so you know exactly when to use it. After that, we get into the really good stuff: how to do this efficiently with a clever trick called LoRA, how to shrink these massive models with quantization, and finally, how to combine them into one super powerful technique called QLoRA. All right, let's dive right in. First things first, what are we really talking about when we say we're fine-tuning a model? This is really the core question, right? If you want to move beyond just using a model straight out of the box, if you want to really make it your own, well, this is where the magic happens. So what's the secret?
Think of fine-tuning as a second round of school. You start with a model that's already got a PhD in general knowledge from reading the entire internet. Then you enroll it in a specialized course, training it again, but this time on a much smaller, very focused data set. And here's the crucial part. This process actually changes the model's internal wiring, its weights and biases. You're not just giving it new facts. You are fundamentally changing how it thinks and behaves.
Okay, so we've got a grasp on what fine-tuning is, but that brings up the next big question. When should you actually do it? Because honestly, picking the right tool for the job is just as important as knowing how to use it. This is the big decision you'll face. You've got a few ways to customize a model. There's this thing called retrieval augmented generation, or RAG, and also in-context learning. So how do you pick the right one? And this table just lays it out perfectly. Look, fine-tuning is all about changing a model's behavior. You use it when you want to change its style, its tone, or the format of its answers. The analogy here is perfect. You're teaching a general expert a new specialty. That knowledge becomes part of them. It's baked in. RAG, on the other hand, is for giving the model new knowledge, especially information that changes a lot. It's like giving that expert a library they can check for the latest facts. You're not changing the expert, you're just giving them better resources.
But here's the catch. This really powerful method of permanently changing the model, well, it isn't without its risks. There's a pretty big pitfall that can actually make your model worse if you're not careful. And it's got a pretty dramatic name: catastrophic forgetting. It's exactly what it sounds like. When you force the model to focus so intensely on a new, narrow task, you risk it forgetting some of the general knowledge it learned in the first place. It's like that super specialist doctor forgetting how to do basic first aid. Not great.
So that sounds kind of bad, right? You want to customize your model, but you don't want it to forget everything it knows. And you probably don't want to spend a fortune doing it. So how do we get the best of both worlds? Well, this is where things get really, really clever. The answer is a whole category of techniques called parameter-efficient fine-tuning, or PEFT. And trust me, this modern approach makes everything more accessible, way cheaper, and much safer for the model's original brainpower. Now, one of the star players in the PEFT world is LoRA, and it has a brilliant solution to our problems. Instead of retraining the whole model, LoRA freezes all of the original weights. It says, don't touch these. Then it cleverly inserts these tiny little adapter layers, and those are the only things that get trained. This means you're only tweaking a tiny fraction of the model's parameters, which just slashes training time and cost. And the best part? Since the original model is untouched, you totally sidestep that whole catastrophic forgetting problem. It's genius. Okay, so we've made the training process way more efficient. Now let's talk about another trick, and this one is all about making the model itself smaller and nimbler. This technique is called quantization, and the core idea is actually pretty simple. You take all the numbers that make up the model's weights, and you just reduce their precision. It's kind of like rounding. Instead of using super precise 32-bit numbers for everything, you convert them to much simpler 8-bit or even 4-bit numbers. The result is a model that's way smaller and way faster. Now, what's really interesting here is seeing the trade-off. Take a look. Our original number is 0.622. When we quantize it down to 8 bits and then convert it back, we get 0.62204. I mean, the loss in precision is practically nothing. Now look at the 4-bit version. We get 0.57142. Okay, so there's a little more of a difference there. But for the absolutely massive gains in size and speed you get, that's often a trade-off you are more than happy to make.
All right, we've seen LoRA for smarter training, and we've seen quantization for smaller models, so you know what the next logical question is: what happens if we smash them together?
You get QLoRA. It's a simple formula, but it represents one of the most powerful and efficient fine-tuning methods we have today. And honestly, QLoRA is a total game changer. Here's how it works. It takes a huge base model and first shrinks it way down using 4-bit quantization. Then, on top of that smaller, frozen model, it adds the smart little LoRA adapters for training. And the result? It's mind-blowing. It lets you fine-tune gigantic models. We're talking billions of parameters on a single graphics card that you could have in your home computer. This is what makes truly powerful AI customization accessible to pretty much everyone.
Hey, if you found this breakdown useful, you know what to do. Go ahead and like, share, and subscribe so you don't miss our next deep dive.
So, you've got the toolkit. You now know how to create your very own specialist AI. The only question left is, what's the first thing you would build? What's the first expert skill you would teach a large language model? Just think about that for a second. The possibilities are absolutely endless. Thanks for watching.